Imagine pressing the brake pedal, and it goes soft, then straight to the floor. No warning light, no gradual, it feels a bit off. Just a sudden loss of hydraulic pressure, because a steel line quietly rusted through on the frame rail. This is not an exotic supercar problem, it's a mass-market system failure hiding in plain sight. In the late 1990s and early 2000s, General Motors built millions of full-size pickups and SUVs on the GMT 800 platform, and in Salt Belt regions, a pattern emerged. Brake pipes corroding and leaking, sometimes leading to partial or major brake loss. This story isn't rust exists, it's how system architecture, routing and failure detectability combine to produce a high-consequence surprise. A brake system feels redundant, dual circuits, ABS, warning lights, so it should degrade gracefully. But corrosion doesn't negotiate with your assumptions. If a steel line perforates at the wrong location, you can lose pressure fast, especially under a hard stop when line pressure spikes and a weakened section opens up. The dangerous part is not just the leak. It's the timing. The first time the driver discovers the failure can be the moment they need maximum braking. NHTSA's investigation focused on salt states, where road de-icing accelerates corrosion on underbody steel components. Brake pipes run along the underside, clipped to the frame. That sounds protected, until you remember what frames collect. Wet dirt packed into crevices, salty spray that dries, then re-wets, abrasion points at clips and brackets, and trapped moisture near modules and bends. Corrosion becomes a slow manufacturing process performed by winter. Here assess what makes this failure unusually is system. Multiple lines converge at components like the ABS hydraulic control unit OSH modulator. In real-world repairs, owners often discover several lines are compromised at once, meaning the system can be one pothole away from going from "see fine" to "gone." This is the engineering punchline. A brake line isn't just a tube, it's a single point of pressure element. Hydraulic systems don't care how confident you feel. Pressure either holds or it doesn't. NHTSA opened an engineering analysis, EA 1101, after a petition and a growing set of complaints alleging premature brake line corrosion failures on 1999-2003 GMT 800 trucks and SUVs in salt states. The report documents large numbers of complaints, alleged crashes, and risk modeling by vehicle age and region. It also shows why these failures are hard to treat as a clean defect signature. Corrosion level varies massively by region, storage and wash habits. Inspection data and complaint data don't map perfectly to real exposure, and fleets and individual owners see very different outcomes. This is where systems fail politically as well as mechanically. The same physical failure can look normal in aggregate, while still being catastrophic in individual events. NHTSA ultimately closed the investigation without a recall, and public reporting at the time emphasized that conclusion. For the owner, that changes nothing about physics. A 20-year-old steel line with salt exposure can rupture today. A closing report is not a protective coating. Lesson 1. Design for inspectability. If a safety-critical part fails invisibly, the system is incomplete. Corrosion isn't rare. Hidden corrosion is a design choice. Lesson 2. Routing is a reliability decision. Clip placement, bends, junction density near modules, and splash zones dictate where corrosion concentrates. Lesson 3. Detectability matters as much as probability. A failure that gives no early signal is more dangerous than a failure that is more common but obvious. Most car disasters on YouTube focus on explosive drama. This one is quieter, and that's why it hits. A mainstream platform, a mundane component, and a failure mode that can reveal itself only at the worst moment. It's a reminder that modern vehicles don't mostly fail like Hollywood. They fail like maintenance schedules and environmental exposure, amplified by routing and system assumptions. A brake pedal is a promise, force in, stopping power out. Corrosion breaks the promise silently, and the system only tells you when it's already too late. This is how systems really fail.